So, sections 3.4 and 3.5 are, 3.4 is solving exponential and logarithmic functions. 3.5 is exponential and logarithmic models. At the end of these lessons, well, this lesson, I will be able to, A, solve exponential and logarithmic equations, and B, use exponential, there's two types of exponentials, right? Growth and decay, going up, going down, and logarithmic equations to model and solve real-life problems. So we're going to spend most of today doing this guy right here, that guy, this guy right here. We're going to spend most of today doing that. Okay, so we're going to basically take a minute to solve each of these logarithmic or exponential equations for x. So the first one, letter A, is 2 to the x power equals 32. Okay? So turn to page, what page is this? I think it's 215? 214. So, let's rewrite 32 as a power of 2. How would I do that? 2 to the first power is what? 2 squared. 2 cubed. 2 cubed. 2 to the fourth. 2 to the 5. 32, right? So this really equals 2 to the x equals 2 to the 5th power. Okay? So what's my solution to this equation? More specifically, x equals 5, right? And what property am I using there? What does it say? It says that because this is a one-to-one function, right? Exponent, let me try that in English. The exponential function is a one-to-one function. So if 2 to the x equals 2 to the 5th, then x equals 5. That's true because this is a one-to-one function. Okay? Part 2, or letter B rather, is natural log of x minus the natural log of 3 equals 0. Okay? So now I'm going to rewrite this equation by adding natural log of 3 to both sides. So then I get natural log of x equals natural log of 3. So what does x equal here? And why does it equal 3, Kane? What property am I using? It's also a one-to-one function, right? So if the natural log of x equals the natural log of 3, then it stands to reason that x equals 3. 1-to-1. Yep. Okay. Now, 1/3 to the x power equals 9. Well, let's check this out. This is tricky. Why is this tricky? I just hit my microphone. That's going to show up on the video. Why is this tricky? Well, think about this. 1/3 to what power equals 9? Why -2, Henry?
You distribute the -2. The denominator will be 3 to the -2 power. That'd be the same as 3 squared.
Yeah, so I'm gonna rephrase what you just said there, make it a little bit more concise. What does the 2 do to 1/3? The 2 flips it? The negative flips it. What's the 2 do? Times it by itself, squares it, right? And 3 squared is 9, right? So the negative flips it, the 2 squares it, turns the 3 into a 9. There we go. So my solution is x equals what? -2. This is also a one-to-one function. Now let's do something a little different. E to the x equals 7. What do I do to the left-hand side of this equation to get me x? I hear one person say divide, I hear one person say natural log. What does the natural log do? If I take the natural log of e to the x, what do I get? What's the base of my natural log?
E.
So e to what power gets me e to the x? Right? Right. So if I take the natural log of this side, what best I do to the other side? Take the natural log of it as well. Right? So, what's my solution? What is natural log of 7? For those of us with calculators or 1.5 something? 1.9 something. Thank you. 1.9 da 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 da. Now, am I using the one-to-one property? What property am I using? I'm taking the inverse of the function, right? So I'm taking, this is an exponential function. I'm now taking the log of that exponential, so I'm applying the inverse function to get me back to x. So, if the natural log is the inverse to e to the x, what is the inverse to natural log of x? If a is the inverse to b, then b should also be the inverse to a, yes? Yeah. So here's what I'm doing. I'm going to take e to what power on this side? I'm going to take e to the natural log of x. And then I got to do the same thing on the other side, e to the -3rd power. Because these are inverse functions, now I get x on this side, right? And what do I get on the other side? Again, calculator practice. guys depressed that you had to come to school today?
Yes.
This is like, the mojo in this class is suffocating right now. I'm sorry, 10.04? Oh, 0.049, because it's a -3, yeah. Thank you, Kane. All right. Now, I got log base 10 of x equals -1. How do I undo that? What's the inverse of log base 10? 10 to the whatever, right? So, in this case, 10 to the log base 10 of x, right? Equals log base 10 of -1. What's the problem with this picture? Oh, wait, why am I doing that? Why did I do that? I took 10 to the log on this side, so I took 10 to the power of this, and then I took the log of that. That's not right, is it? It's not right. See? I knew you guys were dead. You would have caught me on this on any other day. What should be written over here? 10 to the -1 power, right? When I evaluate this, what do I get? I get x. And what do I do when I evaluate this side? 0.1, and that's also the inverse property. Now, if you think about this really hard, how did we translate this before? I said the base to what power equals x, right? The base, so the base to what power equals x, right? What we're doing here is just a different way of saying the same thing we've already said, right? It's just a different way of saying the same exact thing. Okay? And we need to be how should I put this? We need to be able to recognize this when we are being shown, so that we just don't do the, right? So the goal of this class is also to give you multiple ways to express something, because when you're describing something to another person, is it always easy to get it through on the first explanation? Sometimes you need another way of describing something, right? Oh, you guys are putting me to sleep. I think the lack of a snow day on a snow day depression is taking this class by storm.
The road and everything is probably getting over the speaker like 5 minutes into the advisory. It's like, yeah, well, the roads are nice and slippery, so be careful driving.
Well, you know, something about that. It's not up to Donnelly, is it?
I know, it's up to
Dr. Bezik's call, right?
Far away from school.
He lives in like Amory.
He lives in Amory, dude.
Okay.
He's,
And they got canceled off.
he's hiking.
He lives in
All right. So, let's solve. All right, enough carping about the school closure or lack thereof. Let's solve these. Let's solve this the first way that we've learned how to solve this. How did we solve this the first, when we talked about this before? we were able to convert a logarithm into an exponential function, right? Which means we could take that exponential function and convert it back to a logarithm, right?
Sure.
What logarithmic function would that have been?
Natural log of 72.
That's how we wrote it, right? How are we doing it now?
Take the natural log of
We're taking the natural log of both sides, right? So this is how we're doing it now. We're taking this equation right here, and we're applying the natural log to both sides. So the natural log of e to the x equals the natural log of 72. And we know 72. That's what I said, 72. Didn't you hear me, Henry? I said 72, and I wrote 72. Golly. God. God. Now, because we know these are inverse functions, what does this evaluate to, Logan? Natural log of e to the x. Those are inverse functions, right? So if I take the inverse, if I take a function and then apply that function to the inverse, what do I get? Remember the definition of the inverse function. If I take the function and then I take the inverse of that, I get what I started out with. What did I start out with? X. So if I take e to the x and then take its inverse, which is the natural log, I'll get x equals the natural log of 72, which equals 4.276, and we'll just stick to 4 decimal places. Booyah. So, let's try that with this one. However, before I start doing loggy stuff, what do I have to do? No. What's that? I gotta get rid of that 3, don't I? I gotta get rid of the 3. Because am I taking an exponent to, am I taking 3 to the x power? No, I am not. So I gotta get rid of that thing, right?
14.
So now I get 2 to the x equals what?
14.
14.
So you just did 3 times the log of 2 to the x. Does that work?
Yes, but then you're gonna have to divide by 3 eventually, right? Or you could do, no, you couldn't do that. No, you could not do that. I got excited there for a second. And then I was like, stop. Now, how do I undo the exponent?
Log 2 of x equals
Log
log 14.
like that? What's the base of my exponent? No, what's the base of my exponent here?
2.
So what should be the base of my log? 2. Log base 2 of that, 2 to the x equals log base 2 of 14. Right? Our bases should stay the same. Now, I know what this is, right? I know what this guy is because I'm taking the exponent and the log of the same base. So those are inverse functions. I get x. What about this mess? This mess, right? What do I need to do? Josh? Change the base. Change the base. So that's going to equal, how do I do that? Should I do common log or natural log?
Common.
Common log? So I got log of
14, or base, yeah, you got it.
Log of 14 divided by log of 2. What do I get when I do log of 14 divided by log of 2?
Log of 7. Oh,
Three.
3.8 exactly?
3.807354922.
We'll do that. Now, here's what I want you to do. Take 2 to the 3.80735 power and multiply it by 3 and see what you get. Two to that power, 2 to this power, and then multiply by 3. So we're plugging x back in. What do you get? So our rounding error applies, right? But pretty dang close, right? And if we use the whole number, we might actually get 42 on the nose. So let's make this smaller right here. No. No. Oh, I hate that. Sorry. All right. I didn't give myself enough room. All right. How do I do this guy? Is it really that hard?
Yeah, add 3 to both sides. Start with
Add 3 to both sides, so then I get 4 times e to the 2x equals, add 3, right? Hey, Henry, you were up late last night. It's okay. Are you guys still butthurt about that?
Oh, yeah.
Come on. What now? What now? You caught napping in the car, right? With the heater cranked up and like relaxation music going on in the background. What now? What now, Josh? How about now? Well, what do you think? What did I have to do first up here? Yeah, let's get rid of that coefficient, right? So let's just do that. Divide both sides by 4. On the left, I get e to the 2x equals 5/4. Now, Josh, I take the natural log of both sides, right? So I'm going to do this up here so I don't run out of room again. Natural log of e to the 2x equals the natural log of 5/4. Now, what do I get over here on the left side? I get 2x, right? Do we see how I don't get x, even though they are inverse functions of one another? What's my input into my exponential here? My input is 2 to the 2x, right? E to the 2x power. And then when I take the natural log of that, I get 2x. Natural log of 5/4, anyone? 2231. And then, to get x, I simply divide both sides by 2. And I get x equals 0.1116. Yeah, thumbs up, right? All right. Letter D. Letter D. It looks really hard, but is it?
+4.
+4. So 2 times 3 to the 2t minus 5 equals plus 4. Aha! Ah, little math humor there. 15. Then what? You guys thought I was going to lose the fractions. 3 to the 2t minus 5. I'm dividing both sides by 2, right?
Yeah.
15 halves.
Oh, wait. 7 and 1.
Ooh. Now what?
Well, now you would go
Log of both sides.
What?
Log of both sides. What kind of log?
Log 2t minus
Log
5
base.
to 3.
Base 3. Why, Kaylee?
That's the base of the exponent.
Bam! Bam! I couldn't have said it any better myself. The base of the exponent is the log base that you take. So this is going to be log base 3 of 2t minus 5 equals log base 3 of 15 halves. Let's do a neat little exercise. Can we apply the quotient property here?
Yep.
Yeah.
Let's do that. How would I?
Log base 3 of 15.
Oh, I'm sorry. I screwed up. Who sees my screw up? I took the log of the right side, right?
Oh, it's supposed to be 3 to the power of 2.
Ah, yeah, see that? See that?
Yeah.
I should take the log of both sides of this. But did I take the log of the left side?
No.
No. So I would change this in order to make it correct. Good catch, Jake. 3 to the 2t minus 5 power. Did I have a plus 5 in there?
No.
I have, okay. So now, I can evaluate this side, right? What's my left side get me? 2t minus 5. Just for you-know-whats and giggles, let's use the quotient property on this log.
Log base 3 of 15. Log base 3 of 2.
Log base 3 of... You sound dead, but your math acumen tells me otherwise.
Can you imagine? We'd probably stuck on the first problem for Henry.
Log base 3 of 15 minus log base 3 of 2. Now, how would I evaluate that? Change the base. What base should I change to, Riley?
Let's say 10.
Common log? Okay. So
Yeah.
tell me, change the base of log base 3 of 15.
Oh, you want to like thing? Log of 15 over the log of 3.
Log 15 over log 3 minus, since we did common log here, can we do natural log of the other one? Sure I can. Let me ask you this. If I change the base to a natural log over here, do I get any different answer than if I take the natural or the common log? Change. No, you're going to get the same answer because log base 3 of 2 is going to be the same whether you choose to change it to a common log or a natural log. And if you don't believe me, punch it in. Do common log of 2 divided by common log of 3. What do you get?
Oh, common log?
Do common log. Log base 10.
Wait.
6309.
2.
2. Okay, so 0.6309. Now do natural log of 2 divided by natural log of 3. Ho, ho, ho.
Wait, what?
Ho,
Oh, never mind.
ho. Is it magic or is it Memorex? All right. So What was this again? 6902?
630.
Negative 0.6309. And then what's log 15 divided by log of 3? We're doing common log in that one, right? 2.4649. And then, so 2t minus 5 equals, what is that math? That is,
1.8 something.
yeah, 1.834. 8340, really. Okay, now what? Add 5.
Right.
2t equals 6.8340. And then divide by 2. T equals 3.4170. Now, riddle me this, Batman.
Alright.
Let's go back to log base 3 of 15 halves. Change base of that. This side, use common log on your calculators. This side, use natural log.
What base routine?
We're changing log base 3 of 15 halves. You guys are doing natural log. You guys are doing common log. I posit that you get something very close to 1.8340.
Okay. Let's see if you're right.
Yeah.
Natural logs get 1.8340. Common logs, what do you get? Are we ready to push the I believe button?
I believe.
I believe.
I don't even know what to do this. What are we putting 3.4?
Huh?
What are
Log.
we putting 3.41?
3.41. No, we were going back here and applying the change of base formula to this to see if we got that. All right. Next page. We're going to solve an exponential in quadratic form. How wonderful is this?
Yay!
How is this quadratic form? It looks like a hot mess, right?
201.
Here's what we're going to do, though. Oh, how great is that? Let's do this. It's base E, right?
Yes, looks like.
Let's take, I do the natural log of both sides, don't I?
So,
I would think so. I would think so. Do I do the natural log of both sides? Do I do the natural log of both sides? Well, maybe I should do this instead. Maybe I should factor instead. Because
gosh.
is there a summation property in logarithms?
Yeah.
So if I take a natural log of a bunch of stuff added to each other, is there a way to translate this into something else? No, I can change things that are multiplied into adding, but I can't change adding. I can't change adding, so we don't do that. But let's factor this. What times what gets me e to the 2x? E to the x times e to the x. You add the exponents, right? Okay. let's see, this would be minus and minus, right? Why is it going to be minus and minus?
I don't know.
I'm sorry? Yeah, because of this -3, right? And then the only way I know to make 2 is 2 and 1, right? Now, if I take the log of this, I do have a product property of logarithms, right? What base log should I take this? What do you think, Logan? What base logarithm do you think I should take? Should I do common log? Should I do natural log, or should I do log of some other base? Why do you say that, Logan? Because there's an E. Every time you see an E, you should say, please natural log me. So we're going to natural log, and I'm going to do a bracket just to distinguish from my parentheses. Equals the natural log of 0. Right, taking the natural log of both sides. Now, what do I do?
Separate the two parentheses.
Utilizing what property?
The product property.
Product property. So then I got natural log of e to the x minus 2 plus the natural log of e to the x minus 1 equals natural log of 0. Can I just evaluate the natural log of 0? E to what power equals 0?
Error. It's not right. It's a word.
Mm-hmm. Yes. What did we do wrong? What did we do wrong? What did we do wrong? How about we do this instead? How about we, I'm not going to erase. I want my record of my inadequacies to sound and resound throughout the ages. But here's one thing I got. What do I usually do when I do this?
Distribution.
Don't.
Never mind.
Let me ask. Who remembers the zero product property?
No.
Zero product property, right? If the product of these two things is to be 0, one of these two things must be
0.
So it's either this thing or that thing. So we're going to do that. We're going to do e to the x minus 2 equals 0. Or e to the x, God bless America, e to the x minus 1 equals 0. Now what? Let's do this one first. Let's add 2. E to the x equals 2. Now what? Now we natural log, right, Logan?
Yes.
Natural log of e to the x equals natural log of 2. The natural log of e to the x, inverse functions give me x. Natural log of 2 gets me 0.6931. Thank you with the calculator, Kane. Now, everybody do the other side on their own.
Okay.
0.
Syntax error. Wait, never mind.
X equals 0.
Okay. Wait.
Didn't even need to calculate for that one, right?
Well, anything.
E to the x equals 1.
Natural log of anything. That's log of.
And then natural log, both sides. So natural log of e to the x is x. Natural log of 1, right? And then e to what power gets me 1?
0.
0. So x equals 0.
That was crazy.
Put that in a blue box.
Left.
And dog ear that thing. Booyah. Okay?
Wait, here you
So,
go.
solving logarithmic equations.
That was.
Solve a logarithmic equation. You can write it in exponential form. Meaning, I exponentiate both sides. We've done this. We've done this. We take e, so in natural log, to undo the natural log, I take e to that natural log of x. That just gets me what I start out with, which is x. That way, I know x equals e cubed. So what does x equal? E to the third power, right?
7 something.
No, it's going to be more like 10.
Oh,
Because 2 cubed is 8.
yeah.
Yeah. E to the third power is 20.08.
Yeah. I was close.
Wow. I was not as close as I thought I was. Wow. I suppose that's right, because 3 cubed is 27. Yeah, okay. So, let's solve this first logarithmic equation. Natural log of 3x equals 2. So the first step we do is we exponentiate both sides.
Yep.
What base would we exponentiate to?
E.
Why e, Henry?
Because the base of that log is E.
Ah. So e to the natural log of 3x equals e squared. So how does the left side of this equation, Dawson, how's that evaluate?
3x.
3x equals e squared is, let's just write e squared.
E.
Wait, I got this.
And then
Squared.
I'm going to continue this up over here. 3x equals e squared. And then what does x equal?
Well,
Equals E squared over
squared over 3,
E squared over 3. Now,
which is 2.463.
yeah, 2.463. I will be happy with that.
Really?
I will be happy with that.
6. 3.
I do too. I like this better than 2.4603. I like this better. Because this helps our thinking. I don't think 2.4603 helps our thinking. This does, in my honest opinion. Now, letter B. Let us both do letter B, or let us do letter B on our own.
Oh,
So, two,
That's log base 3 on both sides there.
2,
Show me your work.
So do you just put the
Because I
three
want
up?
you guys to get good at showing your work here and explaining your reasoning. Now, I can do one of two things. There are one of two approved processes here that I can use. One is the fact that logarithm is a one-to-one function, right? So then I can just ignore the log base 3's and say 5x minus 1 equals x plus 7. I can do that. Or I can exponentiate both sides. To what base?
3.
Base 3, right? Why base 3?
That's the base of log.
That's the base of the logarithm. So I can do 3 to the log base 3 of 5x minus 1 equals 3 to the log base 3 of x plus 7.
Are you sure you're right?
And then
I'm sure.
that gets me right back to 5x minus 1 equals x plus 7, right?
Add or subtract 1.
So I'm going to show that 3 to the log base 3 of 5x
Yeah,
minus
that
1
sure would give me it.
equals 3 to the log base 3 of x plus 7.
And then I subtracted 8 from that.
So then 5x minus 1 equals x plus 7, and that's algebra 1, right?
Add 1, subtract 8.
Minus x on both sides, add 1, x equals 2.
Yeah. 3. Whoa.
X equals 2. What do you think I need to do first for letter C?
Subtract
Subtract
5.
5.
Subtract 5, okay? So then I got 2 log, natural log of x equals negative 1. Then what?
Divide 2.
Divide by 2. Natural log of x equals negative 1 half. Now what?
Wait a second.
Exponentiate.
Exponentiate.
To the
E
to the L.
to the natural log of x equals e to the negative 1 half. Left-hand side, Kai? Good. X equals
2, 3. Where did it go?
E to the negative square root.
I can do that,
Delete.
or I can do,
0.6060.
oh, I just rationalized a radical. Whoa. Whoa. Wow. Remember that? You guys remember that? That was algebra 2, I think, is the first time you guys, no, geometry.
Yeah, we did.
You guys did that in
We
geometry
did
for
it
the
for
first
like
time.
2 months, too. It's awful.
Really don't remember geometry at all.
Feel really jealous.
Or-
You want to start-
I can just leave it like this.
Yeah, let's do that.
That's not much.
I like this better, don't you?
Mm-hmm.
That
Yeah.
is more precise. This is kind of funky notation, but I take both of those. I wouldn't take this, because we know we're not supposed to leave radicals in the denominator.
606.
All right, we gotta go over something from checking extraneous solutions, but we really don't have time for that. I want to give you the practice set. We just did section 3.4. This is going to be due next Tuesday. Well, 3.5 is also going to be due next Tuesday,
You do both.
but you get a whole week to do this.
Okay, can you scroll just a wee bit more? I need to see page number, sorry.
So section 3.4, you pretty much got all you need to do section 3.4 today. I will put this on the website here in about 5 minutes as well.